My name is Stephanie Saylor and this is the Visual Phasing Workshop. Today we'll be learning how to label who had recombination happen on our different recombination lines. And we'll be using example A of the triad examples. You can find the triad examples in the description box below. There are two main methods for determining who had recombination occur at any specific line of recombination. I'm going to teach you one for this example, and then I'll teach you the next one when we review example B. That way you get a chance to see both methods and see what works best for you. The way I like to do it is I like to think of this as a cookie thief is on the loose, or in this case, somebody is the culprit of recombination. Since we have a recombination line and we know where our points of change occurred on that line, so in both M and N's comparison, where they move from a half identical segment to a full identical segment, and N and B's comparison, where N and B move from sharing DNA in one chromosome to not sharing any DNA at all. We look for who is the culprit of recombination, or the cookie thief, between these two different examples. M and N visited and cookies went missing, and N and B visited and then cookies went missing. So who's the common denominator between both? N. So N is the perpetrator of recombination for this recombination line. So I just insert a text box below that line and I put the first letter of that person's name. And I do this with just the first letter because, as you notice, this line is quite close. So if I tried to type the name for each line, it would just waste my time and take a lot of time. So just the first letter under that line. And then we move on to the next line. And we see here that N and B, when they're compared, move from a no match, that gray-brown at the bottom, to a half match. Yellow on the top, blue on the bottom. And when B and M are compared, they move from a no match to a half match. Yellow on the top, blue on the bottom. We know which comparisons have change occur at this recombination line, the N and B comparison and the B and M comparison. And we can see that between these two, B is the common denominator. So we can go ahead and insert a B below that recombination line because B is the one who had recombination occur. So when we build our maps, we're going to see a change in N's map here at this line, and we're going to see a change in B's map here on this line. Moving to the next line, we see changes in the N and B and the B and M comparison yet again as they move from yellow on the top, blue on the bottom, half match, to a no match, as well as from a half match, yellow on the top, blue on the bottom, to a no match, that gray-brown on the bottom. And culprit that's the same between these two is B. So B was the common denominator between both those instances of change. So B's the one who had recombination occur. Moving to the next combination line, we see that M and N move from a fully identical segment of DNA, where they share DNA on both sets of chromosome 19, to a half identical segment, where they share DNA on only one of their two chromosome 19s. And when we compare N and B in our one-to-one compare tool at GEDmatch, we see that N and B go from not sharing DNA on this portion of chromosome 19 to sharing DNA on one of their two chromosome 19s at this recombination line. So when we look between M and N and B, who's the common denominator? It's N. So we can go ahead and insert N below that line to label N as the person who had recombination occur. On our last recombination line, we see our changes occurred in our bottom two comparisons, where N and B move from a half-identical segment, yellow on the top, blue on the bottom, to a no match, where they don't share any DNA for the last part of chromosome 19, and B and M, where they move from not sharing DNA to sharing DNA on one of their two chromosome 19s. So between N and B and M, which person shows up twice? It's B. B shows up twice. So B is the person who had recombination occur. So we mark that line with a B, and we have marked who had recombination occur at each of these lines. So N had recombination occur here and here. And so we will see changes in their map at these two locations, whereas B had changes occur here and here and here. And so we will see changes in B's chromosome map at these three locations. Now notice we didn't mark any of these for M. So guess what? M is going to have two solid chromosomes across the whole top of this map because they didn't have recombination occur at all. M inherited one chromosome from the maternal side completely intact, as well as one chromosome from the paternal side completely intact. In Try It Example B, take some time now to label who had recombination take place and pause the video.